to Real, the torque sensor capital of the world. This is IDbike. Come on in. Hi guys, today I want to tell you something about our TMM sensor. Actually it's the TMM4 sensor because of the fourth principle we have developed. This is a TMM4 sensor, and what it does is it measures the torque of the cyclist. So the amount of force a cyclist puts on the pedals. This sensor is hidden in the frame. I've got a bicycle here. It's a test bicycle of IDbike with this sensor integrated. And as you can see here, you see the position of the sensor. So the sensor is located in the dropout zone of the bicycle. And what it does is it measures the force of the chain or the belt. I'm going to show you that in a model we have here at IDbike. Yeah, so here we've got a model of the bike. And as you can see here, the sensor is integrated in the frame. For this sensor, 3 bolts are used to attach the sensor to the frame, and as you can understand, it needs a special dropout. So the dropout plate is the piece of aluminum which is welded to the frame. This dropout has a special dimension, so the sensor can be mounted with the bolts here. So the sensor on one side is bolted to the frame, and on the other side the axle is mounted here. And when I press the pedal, so I put force on the pedal, you can see the output of the sensor. So more pressure on the pedal, less pressure. Pressure again, no pressure. How it functions is as follows. So when I press the pedal, you can see there will be a force in the chain. And this force also acts on the rear axle here. So the rear axle gets a force in that direction, and therefore we can measure this force, which is equivalent with the force on the pedal. Now here you can see the sensor which is inside. So what happens is that the bottom part of the sensor gets a force in that direction, and the upper half is mounted to the frame. Because of those 2 zones, which are bending zones here and here, this part below can move a little bit to the front. It's only 1/10 of a millimeter, so 0.1 millimeter maximum, so it's a very small movement, but we can measure it. We can measure it with, on the other side, a magnet which moves toward a magnetic sensor. And I can show you that with a bigger sensor we made to explain the principle. So we can continue with our story. So this is the actual sensor which is mounted in the bike. And we made a bigger model of the sensor. I think it's 5 times or 6 times the dimension of this one. Very well to be used to explain the principle. What we got here is the sensor plate, which is the black piece of metal, aluminum, 7075, which is the basis of the sensor. Then we have got the sensor, the magnetic sensor, which picks up the magnetic field, and we've got a small magnet which is mounted in the magnet holder. In our production, we first install the sensor in the sensor plate. The sensor is mounted with special glue, so it's fixed very well. And then we install the magnet holder with the magnet, like this. And as you can see, the magnet is situated very close to the Hall sensor. Now, when there's a force on the sensor plate, so when there's a force in the chain, the bottom part will move a little bit in that side. So the magnet will move along the sensor, the magnetic sensor. And this causes output change of the sensor. So the output of the sensor will change in accordance with the torque you put on the pedals. The output signal is analog voltage from 0 to 5 volt. So a low voltage, for instance 0.5 or 1 volt, usually is the output signal when the torque is 0, and when the torque goes up, for instance towards 200 Newton meters, then the output of the sensor will rise and will go up to 5 volt. So we can measure the torque in this way very precisely.
IDbike uses the chain force on the rear sprockets to perfectly measure the cyclist's pedal torque. The position of our TMM4 torque sensor is on the inside of the right hand rear dropout, so it's properly integrated in the rear frame. Through the chain force on the rear sprockets, we accurately and instantaneously measure the cyclist's pedal torque in both legs.